Welcome to this explainer. Okay, so this is the one planet humans have dreamed about for literally thousands of years. And here's the crazy part. Within the next 10 to 20 years, you could actually step foot on it. Yeah, I'm talking about Mars. Today, we're diving deep into bridging the gap between deep space colonization and real-life sci-fi survival technology.
Let's dive right into this. Here's our roadmap for today. We're going to look at why we absolutely must leave Earth, how we survive the hostile red planet, what building a Martian city actually looks like, engineering some crazy sci-fi survival tech, and finally, terraforming and human evolution. So starting off with part 1, why we must leave Earth.
Now, you might be wondering, why Mars? I mean, Earth is already beautiful, it's already perfectly livable, so what's the point of abandoning a perfectly safe planet to go to a freezing barren rock? Honestly, that's exactly what I thought too, until I learned one absolutely terrifying truth.
Earth is just not guaranteed to stay safe forever. Think about it. About 66 million years ago, a massive asteroid struck Earth and wiped out the dinosaurs. One single impact ended an entire dominant species. Now just imagine something like that happening today. Modern cities, all our technology, billions of human lives, just gone in an instant. That's exactly why scientists and visionaries are so adamant that we must become a multi-planetary species. Because if we keep all our eggs in one planetary basket, our entire existence is at risk.
Which brings us to part 2, surviving the hostile red planet.
So the question is, if we have to go somewhere else, why Mars? Well, it's a terrifying game of elimination, really, because most planets in our solar system are basically death traps. Take Venus, for example. It's insanely hot, literally hot enough to melt lead and covered in toxic clouds. Landing there? Instant death. Jupiter and Saturn? They're just giant balls of gas with absolutely no solid ground. But Mars is different. A day there is almost identical to Earth, about 24 hours and 37 minutes. It has seasons, a solid surface, and frozen water. But getting there? That's tough. It's a 7 to 9 month one-way journey. And because the planets are constantly moving, we only get a launch window every 26 months. Meaning you can't just turn around and come back if things go south.
And let's be real, things could easily go south. Imagine you finally land. You step outside, and all you see is a vast red desert stretching in every direction under this dusty orange-pink sky. It feels totally alien, silent, and empty. Mars has an extremely thin atmosphere, just about 1% of Earth's density, and 95% of it is carbon dioxide. If you took off your spacesuit out there, you'd pass out in about 15 seconds and die within minutes.
And then there's the extreme cold. We're talking mind-numbing drops in temperature. At its worst, the Martian surface drops to minus 125 degrees Celsius. That is way colder than Antarctica. Even the average temperature sits around minus 60 degrees. Without incredibly advanced thermal regulation, human biology just shuts down. Oh, and if the lack of air and the freezing temperatures don't get you, the invisible threat absolutely will. Radiation. 8. That's the number to remember here. Spending just one single year on Mars exposes you to as much cosmic radiation as 8 years on Earth. Why? Because Mars doesn't have a protective magnetic field like we do. Cosmic radiation just hits the surface directly. In simple terms, Mars is a hostile world that is actively trying to kill you in every possible way. So how do we pull this off? Part 3, building a Martian city.
Despite all those horrors, we are still trying to go there to build a second home for humanity. And companies like SpaceX are stepping up with some wild plans. They're building this spaceship called Starship. It's fully reusable, designed to fly again and again like an airplane, to massively reduce costs. And it can carry over 100 tons of cargo. The sequence of events is brutal but simple. First, unmanned supply missions drop off vital equipment. Second, the bravest human pioneers arrive. And remember, they know there's a very high chance they might never return. Third, they start building underground habitats. And finally, they construct full-on structures using giant 3D printers.
Now, none of this works without one absolute key ingredient: water. Without water, nothing is possible. But the good news? Mars actually has a lot of it. It's frozen at the poles and hidden beneath the surface. By extracting and melting that ice, we don't just get drinking water. We can actually split it into oxygen to breathe and hydrogen for rocket fuel. So water literally equals air and fuel. For shelter, we'll go underground where the soil naturally blocks that deadly radiation. And since Martian dirt is packed with toxic chemicals, regular farming is a no-go. Instead, we'll use hydroponics. This is growing food in nutrient-rich water, a tech NASA has already successfully tested to bypass toxic soil altogether.
Let's move to part 4,
engineering sci-fi survival tech.
To survive those insane physical forces I just mentioned, we have to start merging biology with machinery. When you contrast our fragile human limits against the sheer, hostile vacuum of space, it's honestly staggering. But by combining human ingenuity with things like advanced alloys, specialized motors, and AI-driven exoskeletons, we are essentially proving that a real-life Iron Man suit is no longer just science fiction. It's just a really tough engineering problem.
Actually, it might shock you to hear this, but 4 of the 6 necessary systems for a superhuman suit already exist right now in modern science without breaking the laws of physics. We've got advanced alloys and composites for armor to survive heavy impacts. We have motorized exoskeletons and hydraulics that amplify our strength to lift massive objects. Mini jet engines and jetpacks for flight, those already exist and are being tested. And for the AI side of things, brain-computer interfaces like Neuralink are paving the way for a kind of Jarvis-like control system.
Yes, we pretty much have the suit tech. But, and this is a massive but, we have to talk about power. E equals mc squared. As you probably know, this famous physics equation shows that a tiny amount of mass can produce a massive amount of energy. However, practically speaking, generating that kind of insane power in a tiny space, like Tony Stark's arc reactor, remains completely unsolved. We just don't have the technology to build a safe, compact reactor yet.
And here's the real kicker. Even if we miraculously solve the power issue, we hit a hard biological wall, 9 Gs. The human body basically taps out at about 9 Gs of acceleration. Any more than that, and the extreme speeds, sudden stops, and mid-air direction changes of a sci-fi suit would literally kill the person inside it. Unless we invent inertial dampeners, which absolutely do not exist right now, our own biological squishiness is the ultimate limiting factor.
All right, let's wrap up with part 5, terraforming and human evolution.
Let's zoom out from the immediate survival tech and look at the deep time vision here. What will humanity's extreme evolution on Mars actually look like? The timeline we're looking at moves incredibly fast. We're talking the first humans landing in the 2030s, a permanent base established by the 2040s, small colonies forming in the 2050s, and full-blown Martian cities by the end of the century. I know, it sounds totally unbelievable. But remember, we went from the very first airplane flight to landing on the moon in just 66 years. Progress doesn't just move, it accelerates.
So what happens to the humans who actually live there permanently? Well, Mars only has 38% of Earth's gravity. That's a huge difference. Over generations, children born on these independent Martian colonies will develop entirely different bodies. They'll have different bone density, different muscle mass, completely different cardiovascular systems, all adapted to that lower gravity. Which leads us with this incredibly powerful thought to end on. Children born on Mars will never see Earth. They could become the first true Martians. It's a completely new chapter in human evolution. And the absolute craziest part of all this, you are alive right now as this new chapter begins. The rockets are literally being built today. So the next time you look up at that tiny red dot in the night sky, ask yourself, when humanity finally becomes a multi-planetary species, what role will you play in it? Stay curious, everyone.